The next phase of our analytic process is to perform some rules analysis. When performing rules analysis, there are three parts to the process. Correlation. This is where you match the data sets together and find the discrepancies. Consistency. This is where you consider if there are any inconsistencies in the data itself, perhaps missing fields or values that's causing errors. Variation. This is where you see if your data is outside of the normal limits and displaying any odd patterns. Once you're ready, you'll find most of your rules analysis nodes in the correlation category of the library. However, you may find yourself using these nodes, as well as any of the ones I've discussed thus far, at any phase of the process. Continuing with my graph, I'm going to join the agreements and customer accounts data using a join node. The join nodes allow you to compare and merge data sets. Notice that there are multiple join nodes in the correlation library palette. You would use the appropriate join node based on your needs. Do you only want to output records found in a left data source? Then you would use the join left node. If you want to output records found only in both data sources, you would use the join inner node, and so forth. For my needs, the join left inner will work. This will join my two input data sources and only output records either found in the left or top data source or in both data sources. Perfect. Now I can edit the node. When editing the node, I need to specify what data I want to join on. In this case, the customer account number. I start with the left input key, which is the data that's connected to the first input pin. Then I enter the right input key, which is the data that's connected to the second input pin. Notice that this node pre-populated some code. This code means that the right input is going to use the same column as the one we selected in the left input key field. If the two data sources did in fact have the same column name, then this code would be true. But if I look at the BRD viewer for the second input, I see that my customer account number field spells out the word number instead of using an abbreviation like the first input. So this code would not work for me. The last thing I want to do is sort the input data. This step may be needed in order to ensure proper merging of data. If you do not sort, and it is needed to proceed, an error message appears. This is one common error when using the join nodes. Here's the reason why. Your first data source is properly sorted as ABC, but your second data source is not sorted and goes BCA. When the node tries to merge the data, it's going to look at the first line and not find a match. Then move on to the second line and still not find a match. Therefore, the joining does not work successfully. This is why sorting can sometimes be essential when merging data sets together. It is sometimes good practice just to sort the data even if they may already be sorted. This way, you don't have to worry about firing any errors. Data needing to be sorted is a common error when using join nodes. Now I name and run this node. If I look at the BRD viewer, I see that the number of columns have expanded. Now that you know what the join nodes do, let me show you how they work. Here's your scenario. After preparing your data, you're left with two data sets, one with order transactions and the other with customer information. Now what you want to do is join these sets together to get one data set that tells you which customer made the transaction. There are two questions to ask yourself. The first question is, what field should you use to join on? The second is, what join node should you use? Let's take a look at question 1. If you look at the images, you'll notice the common field of account ID. This would be the field you could join on. In some instances, though, you might find that the two fields aren't named the same, but the contents of the fields are similar. For example, account ID and customer ID. Both are named differently in two separate files, but they mean the same in that they both identify the customer. Now for your second question. Which join node should you use? That depends on the information you're looking for or what's important to you. Let's say you care about the transaction information and you want to continue with that data regardless of whether there is a match to the customer information data. Then you would use a join left inner node. This will give you the data that is in the left data set, the transactions, or both data sets. This means that if there is a transaction without a corresponding customer, that transaction will still appear in the final data set, but the customer information will be null. It'll look like this. Another example would be if you cared about both data sets and you only wanted to work with transactions that have a corresponding customer. For that, you would use a join inner node. This gives you the data that is only in both data. Alongside the join nodes is the lookup node. The lookup node enriches a large source of data in the primary input with a small source of data in the secondary input. Both the lookup and join nodes are similar in their functionality. So sometimes the question becomes, when should I use one node versus the other? The lookup node works similar to the join node, but is best used when dealing with small second data sets. This is due to the fact that the lookup node uses storage on your computer to adequately sort the data prior to joining. This is why the data doesn't need to be sorted when using the lookup node. Here's how the sorting works in a lookup node. Your first data source is properly sorted as 1, 2, 3, but your second data source is not sorted and goes 3, 1, 2. When the node tries to merge the data, it's going to look at the first line and not find a match. It then stores that number, in this case the 1, and places it in the computer memory. It then moves on to the second line, and because the memory stored the number 1, finds a match. It's because of computer memory that we recommend a small record set for the second data to help optimize the performance of your graph. Let me demonstrate a lookup node for you. Now I'm going to combine the data I just joined with the payment methods data. Now take a look at this. This is a good spot in my graph for a bend point. Remember, a bend point allows you to create clean lines in your graph. This way you can easily see how the nodes are connected. There we go. Now I can edit my lookup node. I'm going to combine based on payment method. First, I enter my input key, which is the data that's connected to the first input pin. Then I enter the lookup key, which is the data that's connected to the second input pin. Before I run the node, let me show you the script auto-populated into this node. If you needed to further configure the lookup node, you could alter the code on the Output tab. This works as well with the join nodes I previously used. This brain script code controls how the data is outputted. The default script produces a simple join, meaning the node joins the two data sets together and outputs all data from both sets. If you wanted to create an inner join and output only those records found in both data sets, all you would have to do is remove the hashtag from the Where Matches Found line. This changes the text from a comment to a line of script and would only produce records that match both data sources. For this demonstration, I will leave everything as is. Now I name and run this node. If I look at the BRD viewer, I see the payment method field from the first input, as well as the payment type field from the second input. My data has joined correctly.
And that's the join and lookup nodes.